Last lesson we talked about, we were talking simultaneous equations, and we went through the two main methods. Oh, sorry, I'm being rude. I'm talking over you. Awesome. Substitution method and elimination method. I'm not going to spend too much more time on that, just reminding you that they're the two main methods, and a reminder that we should look for what the most appropriate or efficient method there is for solving simultaneous equations as we go along. So this was an example of where it would be more efficient to use the substitution method. This is an example of where it would be more efficient to use the elimination method. We're going to focus on this problem here. Now, it is from your textbook, but I'm going to solve it in my own styles. So the example 13 is 2 adults' tickets and 3 children's tickets to a cricket match cost £45. 3 adults and 4 children's tickets cost £64. Find the cost of each type of ticket. So I've just chosen this as a relatively simple but nevertheless illustrative example of a worded problem that we need to turn into equations that we can solve. So generally speaking, my method for this is fairly simple, right? So what I'm about to do is a bit overblown for this, but I suggest, depending on the complexity of the problem, you read the question a couple of times. In the first time, with the first time you read through a question, it's the literacy check. Is there any word that's relevant and important that you don't understand? Because if there is, you'll need to look it up. If it's in an exam where you don't have a dictionary, then you're stuffed. Move on to the next question. In this case, I think it's okay. We understand the concept of a ticket. We understand that there are two groups of people there being classified as adult and children. That's fine. We get that doesn't matter if you know what cricket is or not. You can see that it's tickets to something. You can see that they cost £45. That's okay. Hopefully you can determine that funny old symbol next to the 4 is a pound symbol. You can probably work out, because the word cost is next to it, it's some kind of currency. I'm overblowing it for this. I know this is pretty straightforward, this one, but I'm just trying to suggest these are the things you're looking for. 4 children's tickets cost, okay, another cost, £64. Find the cost of each. Okay, great. So I've been through the question. There's nothing, and I've got a general gist of what they're looking for. Then I go through it again, and I try to find out what exactly they are looking for now. And almost always, it's a question or a statement at the end of the worded problem. So in this case, it's find the cost of each type of ticket. I'll circle stuff that I think is really relevant here. Cost, that tells us what we're looking for. We're not looking for the number of adults' tickets and the number of children's tickets that were sold. We don't have the information to work that out. And we're not looking for, and we're looking for like a dollar, or in this case, a pound amount. Okay, fine. And it also says each type of ticket. That's actually important as well. And I encourage students, by the way, to take highlighters or different coloured pens into tests, so you can do that for yourself. You can circle or highlight or underline as you go along when in your reading time, and that just means that you can you get 5 minutes reading time for the end of your exams, not much. But honestly, it saves you making mistakes later on. So find the cost of each type of ticket. I've circled each type because I'd answer this differently if it said find the cost of an adult ticket or find the cost of a children's ticket. Because it says each type, I know I need to find 2 solutions, not just one. Okay, all done there? All good? We go through it again. I'll pick a different colour. How about orange? It never gets used enough. And then I'm trying to find information here. So I've got like, I've got 2 adults and 3 children cost £45. And then I'll change colours again. 3 adults, 4 children cost £64. Okay. So sorry, it's not very dark there if you're looking at it, but nevertheless, I hope that kind of makes sense, that I'm using colour to coordinate the related facts together. 2 adults, 3 children, 45. 3 adults, 4 children, 64. Doing this means that when I'm reprocessing into equations, I can quickly look at I'm not reprocessing the question each time. I'm looking at it and going, okay, I'm linking these three things. I'm linking these three things, etc. Okay, so once we've got all that, for gold standard, you should set up your problem. In a test or an exam, you might not have time to be that fancy because it might be wasting your time. But it does help keep your thinking ordered. So I used two variables. I could have used X and Y. The textbook has used X and Y. I've used A and C. And I've been very clear with what A and C represent. A is the cost of adult tickets. C is the cost of children's tickets. A does not stand in for an adult. An adult is a person, not a number. C does not stand for a child. Same logic. They stand specifically for a number, which is the cost. Okay, then look at our orange facts here. 2 adults and 3 children tickets cost £45. Now, I think I would be overblowing it if I didn't go straight to the thing there. It is 2 adults plus 3 children tickets cost £45. Okay, is that okay? All right. If you can't see that rule, sometimes it might, you can't really quite do it in this problem, but sometimes it's useful to put in other numbers to see what it would mean. Like if the tickets cost $15 for an adult and $10 for a child, what would 2 adults tickets and 3 children's costs look like? Well, I'd have maybe $15, 2 adults, that's $30. Oh, what am I doing? I'm multiplying the cost of the ticket by 2 because there are 2 adults. And if they're 3 children's tickets, if they were $10 each, £10 each, what would 3 children's tickets cost? £30. How am I doing that? Well, I've multiplied the number of tickets by, the cost of the ticket by 3. So again, this is a really simple problem, but the logic of what I'm saying is scalable to lots of different harder problems. You're looking at it, you're processing it, and if you can't see the link between the variables and the numbers you're given, substitute real numbers into the problem and see what it gives you. Okay. And the other fact, of course, we'll just go to straight away now. 3 adults and 4 children's tickets cost £64. So we've got 3 adults and was it 4 children? That was like ages ago. I can't remember it. 3 adults and 4 children cost £64. So now we've modelled it. Once we get it to this point, maths calculations can take over. Okay? So we've got 2a plus 3c equals 45, 3a plus 4c equals 64. I'll do the problem, but I'll see if you can get ahead of me. But before we do that, what method would you use? Substitution or elimination? You've got a 50-50 chance if you've got no idea. Maddie? Absolutely elimination. There are those numbers there. There's nothing I can do to make it to be a nice little A equals or C equals. You can use substitution, but it would be a silly thing to do. Alrighty, I'm going to pause the video. If you haven't written this down yet, you should write it down and then see whether you can get a little bit ahead. Okay, see if what you've done matches up with what I've done. As usual in the elimination method, we now need to make one of the variables coefficients agree with each other. You could choose to make the C coefficients agree with each other or make the A coefficients. I'm going to just, if you haven't done it already, you should number your equations. And I'm going to come up with 2 new equations. I'm going to have equation 1 multiplied by 3 and equation 2 multiplied by 2. So I am aiming to have 2 new equations where the A coefficients agree. So 3 2s are 6, A, plus 3 3s are 9, C, equals 45 times 3, which is equal to 135. Equation 2, 3 2s are 6, A, plus 4 2s are 8, C, equals 64 times 2, which is 124. Okay, I think I chose well then because otherwise I would have had to be multiplying 64 by 3, which is, that's not right, is it? 164, sorry, 64 by 3, which is just a little bit harder. Yeah, 128, sorry. This is not looking too bad now. I strongly encourage you to do the next thing. I see people who don't do it and I think, why make your life harder? Put brackets around the second equation and go with subtract. I do have room, I just haven't got it. I should label these 3 and 4 as well, by the way. So we are doing 3 minus 4. Okay, 6a minus 6a is 0, it's gone. 9c minus 8c is c, beautiful. 135 minus 128 is 7. That's nice and easy. Once I've done that, pop it into one of the 2 OG equations. Don't use equation 3 and equation 4, and work out what a is. 2a plus, I should set it up nicely. So I write substitute c equals 7 in equation 1. So I've got 2a plus 3 times 7 is equal to 45. 3 7s are 21. So 3a is equal to 24. Yeah, sorry, I've been distracted. Florence, what are you up to? What are you up to? And you're following on with, you had the same working out as me? Don't go on to other things. It's rude. 2a is equal to 22, so a is equal to 11. So we've got $11 for the tickets and $7 for the children's tickets. So we've got that far, and I wanted you to see the setting out, because I think this gives you the clearest setting out. What's one more thing that we can do if we've got time? Excellent. Yep. Always a good thing to do. It's not what I was thinking, but you should definitely go, i.e. children's tickets, £7, adults tickets, £11. Miles? Oh, what have I done? 21. Yeah, I got distracted. £12. Thank you. There's one other thing that you can do if you've got time. Eve, do you know what it is? Good. The other original equation, yeah. So we call that the check step. And honestly, you don't always have time to do it. But if you've got time, it's really good, right? Because it's like being given an answer in a test in a way. Check 3 multiplied by 12 plus 4 multiplied by 7 is equal to 36 plus 28, which is equal to 5864. Great. Please, that's exactly as I've got there. Okay, any questions? Alrighty. What you're going to do now is you're going to do a little bit of textbook work. I'm going to pause the video because no one needs to see